In the last video, I described the problem of points and had you think of potential ways of resolving the problem. So we had the situation where A had 8 points and B had 7 points, and there was $100, $50 each was put into the middle, and the game was, the end was 10 points. And the question was, how should they split the money if they lose the coin? And there was a compelling argument for giving A all the money because he's winning, at least at that time. And there is a compelling argument for splitting the money, 50-50. But it seems like the most fair thing is to give A somewhat more money than B gets. Like A gets more than half, and B gets less than half. Because A seems to have had a better chance of winning. And one idea was to just maybe give 7/15 of the money to B and 8/15 to A. And that is slightly more than half to A and slightly less than half to B. And it's not a bad solution, but it's not the most accurate one. The reason why that solution is not so good is if the score was A is 1-0, or if B has no points at all, then by this method, A would always get all the money, and B would get none of the money. Again, even if it's just 1-0 and the game just starts. And some people wrote that as their idea and said, B hasn't gotten any points, so why should he get any money? Another problem with the proportional idea is if the score is 17-18 and it's a 20-point game, then that person would get different amounts of money than if it was 7-8 in a 10-point game. But if one person is 3 points away from winning and the other person is 2 points away from winning, it really doesn't matter how many points they've gotten already. It's how close they are to winning as far as who has the higher chance of winning the game if the game were to continue. So I'm going to show you a couple of methods, including one that only takes a few seconds. But here's sort of the longer method. So imagine A has 8 and B has 7. We could make a tree where there's a 50-50 chance. Let's make it so that if it goes up, A wins a point, and if it goes down, B wins a point. So there's a 50-50 chance that after the next flip, it's going to be 9-7, and a 50% chance that after the next flip, the score is going to be 8-8. So the game is not going to end on the next flip. But it might end, if the score is 9-7, once I get to this point, there's a 50-50 chance that it becomes 10-7 and the game ends, and a 50-50 chance that it becomes 9-8 and the game does not end. Whereas over here on the second toss, there's a 50-50 chance it becomes 9-8 and a 50-50 chance it becomes 8-9. And in any of these three situations, it would have to continue. In this one, it's 50-50 that it becomes 10-8, 50-50 that it becomes 9-9. That would end the game. In this one, it's 50-50 that it's 10-8, and a 50-50 chance that it became 9-9. And in this one, there's actually a 50-50 chance it's 9-9, and we even have a possibility of B winning. Circle that in a different color. That would be B winning. These ones that are blue have A winning. And in the 9-9 situation, it's either going to be 10-9 or 9-10. Same thing with this one. And I'll circle the ones where B wins in red, and the ones where A wins in blue. Now, this is the long way. There is going to be a short way coming, but I just want to show you that this is one way of doing this. Now, to figure out the chance of A winning, we see that, there's 1, 2, 3, 4, 5, 6 sort of things of A winning, and 1, 2, 3, 4 ways of B winning. So you might think that the 60% of the money should go to A, but it's actually different from that, because we don't have to add together how many ways there are for A to win or B to win, but what the probability of getting to that spot is. So what we do is, this first one, in order to get to the 10-7 situation, we'd have to do a 1 in 2 chance of getting to 9-7, and then a 1 in 2 chance of getting to 10-7. So that's 1/2 times 1/2, which is 1/4. So this has a 1/4 chance of happening. And these other three things also have a 1/4 chance of happening, but those don't end the game. This blue over here has a 1/8 chance of happening because it goes like this. We follow the path. So it's 1/2 to get here, 1/2 times 1/2 to get there, times 1/2 to get there. So this one right here has a 1/8 chance of happening. And actually anything that ends on this sort of second level, or this third level I should say, this is like the first level, anything that happens on the third level has a 1/8 chance of happening. And there's two in there, this one and this one, that have A winning. But to get to the fourth level, any of these things on the fourth level has a 1/16 chance of happening, because it's multiplied 1/2 times 1/2 times 1/2 times 1/2. And notice how there's 1, 2, 3 of those. And when I add these things all together, I get 4/16 plus, this is 2/8, so it's another 4/16 plus 3/16, which is 11/16, which means that's A's chance of winning this game, whereas B's is only the rest, which is 5/16. As far as $100 go, 11/16 of $100 is $68.75, and 5/16 of $100 is $31.25. Now, this is not the shortest way of doing it, but it is a way of doing it, and as sort of a challenge question, could you work out what the payout should be in the situation where A has 9 points and B has 6 points? Okay, so take a minute and use this sort of tree diagram to work out that question. Okay, so hopefully you came up with a diagram like this, where on this level it's 1/2, and then A can win once on this second level, which is 1/4, and A can win once on this level, which is 1/8, and A can win once on this level, which is 1/16. That's 8/16 plus 4 plus 2 plus 1. Which is 15/16. And that leaves 1/16 for B, which would translate into $93.75 for A, and only $6.25 for B. Notice how that's a lot better for A than if you did a proportional thing where you gave 9/15 to A and 6. So if you thought that like the proportional thing is always unfair to B, because if B has 0, he gets no money, it also could be unfair to A. And this other system is more fair. Notice that for B to win, he actually has to run the table and get 4 in a row. And to win 4 in a row is difficult. It's 1 out of 16. Now there's going to be a shortcut, but to explain why the shortcut works is, let's go back to the 8-7 situation. So it's 8-7, 9-7, 8-8, 10-7, 9, 8, 9, 8, 9, 9. Now, one thing I want you to notice is that when the score is 8-7, in the worst case scenario, its game is going to be over in 4 flips. 4 flips at most remain. And this is because in the worst case scenario, it turns into, the way I think of it, how many flips for it to become 9-9? Well, A would have to get 1 to get 9, and B would have to get 2 to get 9. But then I add 1 to that because the next flip would change the score. If you want like a formula for it, you could say 9 minus 8 plus 9 minus 7 plus 1 equals 4. Sort of, if I get to where I need a final tiebreaker, this is like 9 is 1 less than 10. You could, I suppose, also say 10 minus 8 plus 10 minus 7. I think it would be minus 1. 2. And then minus 1 would also get you to 4. I personally like this way of doing it. Now, just because there are 4 flips possible in the worst case scenario, doesn't mean the game is going to actually take all 4 flips. For instance, it could end after just 2 flips. Now remember how all these things had different probabilities, like depending on how many levels it went out? Well, what if I had to keep playing so that I actually did all 4 flips, even if they were unnecessary? You might say, well, there's no reason to do that. We already have this thing, and that's got a 1/4 chance of happening. But let's just say I kept going, and I did a 3rd flip, and now A is potentially winning 11-7, even though the B has no chance to win anymore. But let's just say they keep on playing. So this would be 10-8, 9-9. Again, A has won at this point, and he's already won in all these, these guys also. But let's just circle the time when he first got to 10. Now these things are both people winning. But let's just say we're just going to play all 4 tosses, because this is going to make it easier to analyze and to get an equation for. This now he was 12-7, 11-8, 11-8, 11-9, 11-8, 10-9, 10-9, 9-10, B wins. 10-9, 11-9, 11-8, I mean. 10-9, 10-9, 9-10, 11-9, 10-10, which seems weird, some kind of tie if they kept playing out all 4 tosses. 10-10, and 9-11. So you might say, well, why would I possibly worry about playing more tosses after the game is totally over? Well, here's why. Each of these things here has a 1/16th chance of happening. And remember how this 10-7 had a 1/4 chance of happening? Well, if I take all the ways that starting at this 10-7 that the game could continue, not only will he have won the 10-7, but he'll definitely have won after 4 more tosses, potentially, or after 2 more tosses, sorry, after 4 tosses altogether, potentially winning 12-7, but he can't lose. So if you take these 4 things together, it's 4 over 16, which is going to be equal to the 1/4. So what I'm getting at is that if we let the game keep going until we're sure that somebody is going to win, because 4 tosses is the worst case scenario, it might be easier to analyze these 16 cases. And that's what's going to happen. So here, I'll show you a medium way of working out those 16 cases are, when you toss a coin 4 times, from the beginning I'm talking now, from the time that the score was 8-8, there are 16 things that can happen, ranging from heads, 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 down to tails, 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 tails. Here's a list of all of them. Okay, so here are the 8 things that can happen. Now, if the score is 8-7, we're basically asking which of these sequences of 4 letters has, let's say H is A winning, has at least 2 H's. So that means I could have 4 H's, or I'll make in blue the ones with 3 H's. And then I'll make in green the ones with 2 H's. So having 2 H's, 3 H's, or 4 H's is going to make A win. And if we count these up, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of the 16 things that can happen when you flip 4 coins are A winning. Well, let's see if there's a way to calculate these without listing them, because suppose they weren't just 4, but it was like 8 more tosses at the worst case scenario, or the score was 1-0 when there was, practically 20 tosses in the worst case scenario. Well, these can be done with combinations, because the HHHH is the same thing as saying 4C4. There are 4 letters, and all 4 of them are H's, and 4C4 is equal to 1. For the blue ones, it's going to be 4C2, because there are 4 sort of coin tosses, and 2 out of the 4 are going to be heads, and 4C2 is equal to 6. Oh, sorry, I should have said 4C3. 3 heads and a tail, which is 4. And then finally, 4C2, which equals 6. And those 3 things add up to 11. And in the denominator, we put 2 to the 4th power. So this gives us a nice way to do it. By the way, I could also say, I could count the heads and the tails instead of the heads. So I could say 4C0 plus 4C1 plus 4C2. So notice this 2 is how many points A needs, and the 4 is the worst case scenario of how many tosses it might take. And in the denominator is 2 to the 4th power. So I'll write this now as on this one. So that answer ended up being 4C0 plus 4C1 plus 4C2 over 2 to the 4th power. This 4 is all these 4s are all because 4 is the most amount of points left. And this one, these C's, you just go from 0, 1, 2 is how many points A needs to win. So would you now take a second to take the situation where the score is 9-6 and create an expression kind of like this. And then you can calculate it out also. So take a second to do that. Okay, now for this one, it's going to be four tosses again. That's because if in 3 tosses it could become 9-9, and then one more is going to be the winner. So it's still going to be 2 to the 4th in the denominator, and it's still going to be 4C0, but it's just going to be 4C1 here, because A only needs one point to win. So 1 plus 4 over 16, or 5. I just realized that something went wrong. Remember back here where I just changed it from going backwards until I hit this number, and I changed it to going forwards till I hit this, till I had the same 3 terms? It was sort of a coincidence that it ended up being the same thing. Let me go back to this way of doing it. So if there's 4 tosses left, and if A wins all 4, or he wins 3, or he wins 2, or he even wins 1, he's going to win the game. At this point, if you want to change it to 4C0, 4C1, 4C2, 4C4, you could, but probably not necessary. And this is why it becomes 15 over 16. Sorry about that. I probably confused you with that other one. Maybe I'll do one more. Actually, let me now show you the nice slick shortcut. Now, these numbers, 4C4, 4C3, 4C2, 4C1, are nicely put onto Pascal's triangle. So back to A is 8, B is 7. First we figure out there's 4 left at most. So in the denominator I put 2 to the 4th power. But now the sneaky trick is if, oh, by the way, this is 14641. What we can do is see how many points does B need to win. He needs 3. And you can take the first 3 numbers of this Pascal's triangle row and add them together. And we get 11 over 16, which is the answer. These numbers also represent, this is A getting 4 wins in a row, 3 wins in a row, and or 2 wins in a row. Let's try to do one where the score is 8-5. So would you create a fraction, and here's a nice little Pascal's triangle. 1, 5, 10, 10, 5, 1. Maybe we need 1, 6, 15, 20, 15, 6, 1. Okay, can you create a fraction using the new sort of shortcut for the score being 8-5? Okay, first we figure out that for the score to become 9-9, for the score to become 5-9-9, he would need 4 more points. He would need 1 more point. So that would be 5 points just to get to 9-9, plus 1 more would be 6 points in the worst case scenario for somebody to win. That's like if it became 9-9 after 5 points and then one person won the next one. So we have to take this column, and the denominator is 2 to the 6, because
The 6 becomes the denominator. And here I can take the first 5 numbers, the 1, 6, 15, 20, 15, and add them together. I'll just write it like this first. When you add those together, you get 30, 50, you get 57 over 64. And that's how much A would get versus 7 over 64 for B.